Particular one, my goal here was to review that probably the most forgotten way of graphing lines is using x and y intercepts. That was my goal with this one. So like say if I'm looking at this red graph, if I plug in 0 for y, that finds my x-intercept, and I can tell it'd be -4. -5 times -4 gives me 20. So that's where I got this point from. My y-intercept, if I plug in 0 for x, then I could tell that 20 divided by 8, that's 2.5. That's where I got this point from. So remember that you can always find your x and y-intercepts if you want. But there's one situation where your x and y intercepts won't be enough. Let me show you that, just in case you ever run up against this. Let's say if I have 3x plus 5y equals 0. Okay? If I have that, and I'm trying to, there we go. If I'm trying to graph this using my x and y intercepts, I encourage you to use this little table if you need to. Boy, I drew that big. 0 for x, 0 for y. That'll get you organized. If I plug in 0 for x, what y makes that true? 0. You guys should all be screaming, 0, 0. Because 5 times 0 gives me 0. Okay. And if I put in 0 for y, what do I get for x? 0, because 3 times 0 gives me 0. So if I graph this, I get the point 0, 0. And the other point, 0, 0, that's not enough to graph the line. Because who knows? It might be this, might be this. We need 2 points to graph a line. So one thing we're going to work on today is we're going to work on what we can do in that situation to find a slope. Well, here we go. Well, actually, that's more tomorrow, but 3x plus 5y equals 0. If I subtract 3x from both sides, 5y equals -3x, divide by 5. So then I have y equals -3/5 x. And I'm hoping you have some recollection of what you did. I don't know, hopefully it was in some geometry, some in Algebra 1. But this has a slope of -3/5. So how do I get another point? I go down 3 over 5. Down 3 over 5, and then there's my second point. So today we're going to talk about two things. We're going to talk about slopes, and we're going to talk about graphing with y equals mx plus b. Okay? So, get ready. Let's go. I don't even know what section this is. Kind of deviate from the book a little bit because I really don't like this book. We are section 1.5. First thing we're going to start off with is slopes. Slope is a critical idea. From here on out, slopes are going to be part of every single math class you ever deal with. Okay? Slope deals with a ton of different things. I'm saving any applications for tomorrow. Today I just want to work on skills, understanding the concepts, and then we'll throw in some real world stuff a little bit later. Okay? First of all, slope. There's one word or one letter we usually use to represent slopes. Anybody remember what it is? M. And the reason that is, at least this is my opinion, it's the French word for to rise is monter. So that's why I think they use M for slope, but who knows? There's no written documentation. But I think there was, some early mathematician was like, oh, we need to pick something for slope. What should we pick for slope? I don't know. How about to rise means monter? Let's use M. Let's use M. And then everybody was like, oh, that's a great idea. Okay? So that's my opinion. I think that's probably what happened. Okay? So slope is what over what? Rise over run. Glad to hear you guys saying that. Rise over my run. And my rise is my y's, So it's delta y over delta x. My guess is you guys haven't used delta a lot before, but you probably have in science for like delta T. That means the change in temperature. Okay? But delta means change. How much did my y change? How much did my x change? Okay? And there's another way we could do it. You go y2 minus y1, x2 minus x1. Because if you want to know how much something changed, you subtract. Okay? My weight used to be 185. Now it's 230. So I'd have to subtract 230 minus 185 to find out that, yes, I've gained 45 pounds. That's awesome. Yeah, that's great. I need to fix that. Okay? So let's talk about just a couple things with slope. I think you need to have some visual understanding as to what slope is. If I cut this in half, then I have a 45-degree angle. What's the slope of that dotted line? Anybody know? Okay. It's 45 degrees. So that's kind of one way we can talk about incline. But if we talk about slope, it's just a numerical value as a fraction. Let me put some points on here. A point that might be on here is like 3, 3. 5, 5. It's 1 over 1. Okay? Because if I rise and run the same, there's lots of different ways I could express it here. I'm not going to write all these down, but I could go up 3 over 3. I could go up 2 over 2, or I could do the big thing, up 5 over 5. They're all the same. 3 divided by 3, 5 divided by 5, 2 divided by 2, they're all 1. So my slope is 1. Okay? If I wanted to go the other way, at negative 45 degrees, oh, by the way, if you didn't know this, if your dog has conjunctivitis or pink eye, guess what? You can get it from your dog. Did you realize that? If you pet your dog, I'm no longer contagious. But sometimes I just get an itch in my eye. So yeah, if your dog has some goop coming out of its eye, you might catch it if you're not careful. So anyway, so the one that's going downhill, what would the slope of that one be? Not 1, but negative 1. It's going downhill. Slope equals negative 1. So then it's going to beg well, first of all, I'd like you to understand that it's not just, it doesn't have to go through the origin to have a slope of 1. If I raise it up and keep the angle the same, all those still have the slope of 1. All these still have the slope of 1. They're going uphill from left to right, and they're going uphill at that same rate. This one, same thing. Those all have a slope of negative 1. Okay? All the time. Then it kind of begs the question, what if I have something that's horizontal? Let's think about this in terms of rise over run. If I'm going from one point to the other, this is not a trick question. What's my rise? 0. I'm not going up at all. My rise is 0. So my slope is 0 over, let's say my run here is 2. Okay? What's 0 divided by 2? 0. Are you sure? It is 0. If you take a candy bar, cut it into 2 pieces, but don't eat any of it, you've consumed 0 calories. It's totally possible. It's not easy to not eat it, but hey. So that is equal to 0. So that's one thing you need to have figured out. Horizontal line, my slope is 0. Okay? We'll summarize this all tomorrow a little bit too. What if I had something vertical? If I go from the bottom point to the top point, I've got a rise. Let's say my rise in this case is 4. What's my run? 0. This is the one that everybody gets wrong. 4? It's 4? 4 divided by 1 is 4. Get your calculator out. What does it say? 4 divided by 0. I'm curious because different calculators say different things. Divided by 0, error. Anybody say anything different? I don't like to use no slope, and there's a reason why. But, so I don't know if your prior teacher, said that. To me, I prefer to think about this floor having no slope. Okay? So what's the slope of this? So it doesn't have any slope because it's flat. Okay? So that's what I think. That's the common sense. That's more of a common sense deal. So this one, the slope is undefined. So it doesn't have a slope that we can really talk about. It's vertical. I kind of look at it this way. If I walk across this one, my slope is 0. If I walk across, wait a minute, I can't walk across that. I would need like Spider-Man suction cup hands and feet to do that. Okay? Okay. So what about if I had, so right now I've got 1, and this one we talked about, that slope is 0. What might be like somewhere through here? Give me an example of a slope that might be somewhere through here. 1 over 2. All right. Rise 1 over 2. Rise 1 over 10. Rise 2 over 3. Okay. All of these over through here are going to have like a fractional slope. 1/2, 1/3, 1/4. So here, technically, my slope is between 1 and 0 through here. Here, my slope is greater than 1. But that's not what I want you to necessarily focus on. I just want you to focus on if it's flat, it's going to be less than 1, either positive or negative. And also, if it goes downhill, it's negative. If it goes uphill, it's positive. So this one's going to have a negative slope. This one's going to have a positive slope. If it goes downhill from left to right, it's going to be negative. Uphill from left to right, it's positive. Okay. So, what am I going to do here? What did I do? Okay. So one of the things you're going to be asked to do on your assignment here is you're going to be asked to plot points. I know plotting points, you guys all should be able to do that with your eyes closed. Well, not necessarily with your eyes closed. That'd be kind of tough. Okay? But anyway, 4, 4, got it. 1, 2, got it. To find my slope, up 2 over 3. So my slope is 2/3. Could I also write my slope as down 2 over negative 3? I could. What happens to my negatives? Yeah, my negatives cancel. Okay? My negatives are going to cancel. So it's just the same as 2/3. It doesn't matter if I go uphill to get it or go, down, that's negative. Over to the left, that's negative. Any movement to the left is negative. Any movement to the downward is negative. So you've got to pay close attention to that. Okay. So now what if I did this? What if I said, I just gave you points instead? 3, 6, and 5, 10. And I wanted to find my slope. Would you have to graph this? No, you don't have to graph it. You can just go ahead and either one of a couple things. You could use your formula, subtract my y's over subtract my x's, and that's your slope. So here we go. Let's do it that way. 10 minus 6 over 5 minus 3. That would be 4 over 2, which is 2. If you went the other way, this one I went 10 minus 6. If I went the other way, look what would happen. 6 minus 10 over 3 minus 5. Negative 4 over negative 2, which negatives cancel, and I still get 2. It doesn't matter which direction you go, as long as you go the same way on your y's and your x's. But you know what? I think we're smart enough to do this a little bit in our head as well. Because if we think about this, it's really the change in y over the change in x. I think we can look at this and see from 6 to 10. How much did my y change? 4. It went up 4. From 3 to 5, how much did my x change? 2. 4 divided by 2 is 2. Okay? So if I give you 2 points, I expect you to be able to find the slope. So right now, what am I going to expect you to be able to do? Plot points from a graph, be able to tell the slope. Be able to tell the slope from a graph. Given 2 points, find the slope. And then one last thing. If I give you an equation, we're going to use this form, y equals mx plus b. I want you to be able to graph it. That's my y-intercept, and that's my slope. Always. If y is by itself, that is always the case. You might think, why is that always my y-intercept? Because if I plug in 0 for x, that's the only thing left for y. So that's my y-intercept, using our old rules that we learned last week. Let's do a couple examples here. Y equals negative 2/3 x plus 1. Okay? You've done this before. You've done this before. So start at your y-intercept of 1. And then from there, what am I going to do? Down 2, over to the right 3. So a negative rise, and then over to the right 3. So I'm going to go, and there's my other point. So start your y-intercept, and then from there, use your slope, down 2 over 3. So another example. Oh, let's just go y equals negative 2x. Trying to throw a couple wrenches into the works. What's my y-intercept? Yeah, because they're not adding, they're not subtracting, so it's just 0. If you could write it as plus anything, it'd be plus 0 if you wanted to. So you're going to start at 0. So now negative 2, for us to read that as rise over run, you got to write it in terms of a fraction. So I'm going to go down 2, over to the right 1. And that one's pretty steep. Because the slope is -1 would be a 45, -2 is even going to be steeper. What if I did something to totally funk you up here? What if I said x equals 4? To graph that line. If it looks different, you might have to go to a different mode. X is 4. So here I've got the point 4, 0. Here I've got the point 4, 2. Here I've got the point 4, 5. What's always true about all those points?
X equals 4.
My x is 4. Okay, so I'm going to give you GABA time to work today. So here we go. This front page, like I said, easy peasy. Plot points, count your slope. Making sure that everybody is, all your skills are up to snuff. If not, if after doing this little packet here, if you're still struggling with finding slope, that's something you need to come in and work on. Find slope, graph lines. Do not do the back page yet. Don't do the back page yet. Okay? Go, get the rest of the time. Oh, I'm sorry, they're right there. You might need that, huh, Tegan? Oops. So I'm going to just go ahead and zoom in on the parts for maybe people who aren't here. They can at least find a way to do some of it. You can do a screenshot if you want. Oh, I am still recording. That's good. Here's the answers on the bottom. The back, if you screenshot this, you can get this part done.